Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is the 13th video, guys. It's the last video. Please note that I've already uploaded other 12 questions, guys, and all of these questions are extracted from past question papers. Né? It's very important for you guys to know how to tackle such questions because it will give you an edge whenever you write your exam. So please do make sure that, guys, you answer all of these questions, né? And do share the video to your peers so that they will have an edge as well. Okay, 2-point charges X and Y are held 0.03 meters apart as shown in the diagram below. The charge of X is negative 7.2 nanocoulombs, while the charge on Y is a positive 7.2 nanocoulombs. Okay, we have two unlike charges. They will definitely attract one another. Né? Okay, firstly, they want us to state Coulomb's law in words. It simply states that the electrostatic force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of their distance apart. Okay, and then now they want us to draw the net electric field pattern due to the 2-point charges. Since you don't have enough space, né? I'll draw the pattern over here. These two will attract one another together, and since they have the same magnitude, the number of field lines should also be the same. But remember that, guys, the arrows should point from the positive charge pointing towards the negative charge. Are you together? Yes, that's how it should be. Then now they want us to calculate the magnitude of the electrostatic force between sphere X and Y. I know that F is basically K Q1 Q2 over R squared, right? And K is just 9 times 10 to the power 9. The magnitude is just 7.2 times 10 to the power negative 9. And another 7.2 times 10 to the power negative 9. Ne? All over the distance apart, which is just 0.03 squared. And then whenever I punch my calculator, I'll simply get 9 times 10 to the power 9, and then I have 7.2 times 10 to the power negative 9. I wrote negative 6 there. To the power negative 9 squared divided by 0.03 squared. So this will basically give me 5.184 times 10 to the power negative 4 newtons. So the electrostatic force between the two charges is just 5.184 times 10 to the power negative 4 newtons. And yes, it's an attraction force, né? Okay, I should have written this there, but it's okay. And then now we are told that a third point charge Z of unknown positive charge. Okay, we now know that Z is positive, and it is positioned 0.01 meters to the left of X on the line joining X and Y. Okay. Firstly, they want us to draw a labeled vector diagram showing the direction of the electric field of draw a labeled vector diagram to show the directions of the electric fields at the point where sphere X is positioned. Remember that, guys, electric field is always in the same direction as the electrostatic force, né? I know that if this is Z over here, if that's Z over there, I want to see how is Z going to behave due to sphere X. Are you together? They both have different signs. This is positive, the other one is negative, so they'll definitely attract one another. Are you together? So sphere X will basically attract to sphere Z. Ne? So what will simply happen is that sphere Z will be moved towards the right as a result of charge X. So this is the electrostatic force between X and Z. Are you together? And then the electrostatic force between Y and Z, they are both positive, so they're basically pushing one another away. But I'm only focusing on Z, so Z will be basically pushed towards the left. This is the force between Z and sphere Y. Z and sphere Y. Are you together? So remember that, guys, the electric field is always in the direction of the electrostatic force. Are you together? So that means I'll simply have EY over there, the electric field due to sphere Y, and then EZ over there, the electric field due to sphere, the electric field rather due to sphere X. How? Seconds on much. The electric field due to sphere X. Are you together? So you could have drawn your free body diagram like that. Okay, and then we are told that the magnitude of the resultant electric field at a point where X is positioned is this. So we are given the magnitude of E net. They want us to find the charge on Z. We are given the E net. Actually, I just answered something they did not ask me. Excuse me about this, guys, ne? Because I was checking how is Z going to behave. And the question, they wanted us to draw the electric field of at point X. Excuse me about that, ne? So X is our reference point. So I'm looking at how is X going to behave. Excuse me about that, ne, guys? Okay, if this over here represents sphere X, let me check how is X going to behave as a result of this positive charge over there. They will attract one another, firstly. They will attract one another. So it simply means that X will be pulled towards the left. This is the force between UZ and X. Are you together? And then now let me check the relationship between X and Y. Obviously this one is positive and the other one is negative and the other one is positive. So they'll definitely attract one another. So X will be pulled by sphere Y towards the right. So this is the force. This is the force between sphere Y and sphere X. Are you together? But remember that, guys, the electric field is always in the direction of the force. So since X is our main reference, so that means this will be the electric field experienced due to sphere Z, and that's the electric field experience due to sphere Y. So you can just remove these two over there. So this is the vector diagram, né? And then now we are given the net electric field at point X. They want us to calculate the charge on sphere Y. Okay, all I have to do, guys, is to choose a positive direction, né? If the left is positive, that means the right hand side is negative. So that means my E net is basically equals to the electric field due to sphere Z minus the electric field due to sphere Y. Are you together? The E net is just 4.91 times 10 to the power 5. This is equals to, I do not know the, okay, but let me just substitute. That's K KQ over R squared minus KQ over r squared, ne? 4,9 times 10 to the power 5 is equals to 9 times 10 to the power 9 multiplied by the charge of z all over the distance between x and z is basically 0.01 squared minus 9 times 10 to the power 9 multiplied by 7.2 times 10 to the power negative 9. Yes, and the distance between the two is just 0.03. Okay, so for me to find the sphere z, I just need to calculate this first. But before I do that, I have 4,9 times 10 to the power 5. Now, if I punch this on my precious calculator, if I punch this on my precious calculator, this will give me, that's basically 9 times 10 to the power 9 divided by 0.01 squared. This is just 9 times 10 to the power 13 multiplied by qz minus, and then that's basically 9 times 10 to the power 9 multiplied by 7.2 times 10 to the power negative 9 all over 0.03 all squared. This is just 72,000. So I'll basically have 4.9 times 10 to the power 5 plus 72,000 is equals to 9 times 10 to the power 13 multiplied by qz. So for me to find the magnitude of the charge, I just need to divide both sides by 9 times 10 to the 13. That's 4.9 times 10 to the power 5 plus 72,000 all over 9 times 10 to the power 13. 4.9 times 10 to the power 5 plus 72,000 all over 9 times 10 to the power 13. So this will give me a charge of positive 6.24 times 10 to the negative 9 coulombs. That's 6.24 nanocoulombs. So the charge on Z is basically equal to 6.24 times 10 to the negative 9 coulombs. And it's positive. That's the charge over there. So that's how, guys, you're supposed to tackle this question. Eh? I really hope that, guys, the videos are really helping you out. So if there are things you're not sure about, please do ask on the comment section. I'll definitely come back and assist you.